1.7. Okay, so what we did before, we started with just numbers, and if you were going to simplify a fraction with numbers in it, you say what are the factors. So we actually factor these, break them down into what they multiply. And if they have a common factor, you can cancel the common factor, and the answer would be 5/3. So we're doing the same thing. We're breaking down an expression into its factors, the two brackets that are multiplied, and then if they have a bracket in common, you can cancel them. That's the idea. We also saw things like this, for instance. What cancels in this one? 2x squared over x cubed. X squared, right? Not the 2, but this is 2 times x, and on the bottom is x times x times x. So 2 of the x's cancel, or an x squared cancels. We're left with 2 over x, right? And then an easy factoring one, say we had 2x plus 2 over 3x plus 3. Ideas? So right now they don't cancel, and you never cancel anything with a plus sign in between anyway. So and 2 over 3 doesn't simplify anyway, but it has to be multiplied. So can you factor out a 2 in the top? And what can you factor out in the bottom? A 3. So if we factor out a 2, we're left with an x and a 1. And if we factor out a 3, we're left with an x and a 1. So we can cancel and have 2/3. Now, do you remember being told anything in high school about canceling out x's? It actually changes the problem a little bit, because before, what number could you not plug in here on the bottom of the fraction? What would make a 0 on the bottom? Yeah, -1, like is -1 plus 1 is 0? That would make a 0 on the bottom, -1. I'm just going to put over here, x cannot equal -1. So if we had put a -1 in the bottom, so what I'm saying is the bottom can't equal 0, because you can't divide by 0. And what would make the bottom equal to 0? -1. So we cannot use x equals -1 in the original question. So just like with radicals, we always check our answer in the original, because even though you get an answer, it may not work in the original question that was being asked. The same here. If you cancel out something with an x in it, there was originally a number that didn't work, and it was -1. So x can be anything except -1 in this question. So no matter how you simplify it, you still have to kind of keep the same domain, the same x values that work. So that's what we would put at the end. So we're going to start doing that when we cancel out an x. What about this last one? I ignored it. But we did cancel an x. What makes the bottom of this 0? What makes the bottom of this 0? 0. What makes the bottom of the answer 0? So did I change the question, or can you still plug in anything except 0? Right, I didn't really change it. Although it wouldn't be wrong to say x can't be 0 on the end. It's not wrong. It's just it wasn't needed there because I didn't change the domain. I didn't get rid of an x that was on the bottom. It's still there? Okay. All right, next question. Nothing cancels right now because there's nothing written that's multiplied, and you can only cancel things when they are multiplied. So we can't do anything yet until we factor it. So these are just a is 1. So these are the easy ones. Once you find the numbers, you have it. So on the top, we want two numbers that multiply to give a -2 and that add to give a -1. So what numbers multiply to give -2? 2 and 1. The negative has to be on the 2 to make that a negative. -2 and 1. On the bottom, we have to multiply to give -8 and add to give +2. So the -8 means actually subtract to give -8, or subtract to give 2. What two numbers multiply to give 8? 4 and 2. And 4 and 2 do subtract to give 2. So 4 and 2 are the numbers. You can actually just stick them right in here and then say what do the signs need to be to work. So they want to add to give a +2. So the 4 has to be plus and that has to be minus. 4 minus 2 is +2, and 4 times -2 is -8. Now does anything cancel? Yes, now they're multiplied. You can cancel the whole bracket out if something cancels. And we're left with x plus 1 over x plus 4. And that would be your answer. And you can't cancel these x's out. They're added, they're not multiplied. You can only cancel when it's multiplied.
So in that case, we can do x not equal...
Oh, yeah, yes, so. What did I cancel out that you can't see here anymore is the x minus 2. What makes that 0? X minus 2 equals 0 is x equals 2, so you can put that at the end. Okay? So really that's sort of getting into chapter 2, which is all graphing, and we have to do that every time. Here it's not so important because we're not actually using it for anything, but we'll start doing it because later we're going to have to do it when you're graphing. Okay. All right, next example. 3x squared minus 12 over 2x plus 8. So I told you your first step should always be, can I factor out a common factor before I start? And what's the common factor on top? 3. So then I have x squared minus 4. Remember, you're dividing, like 12 divided by 3. And on the bottom, we can take out a 2. 8 divided by 2, 4. All right, now can we factor either the top or bottom further? The top? Yeah, it's a difference of squares. Right, so x squared minus a number can be factored further. So on top, on the bottom we can't, it's just x plus 4. On the top would be what? X plus, no? 2. Careful. Right, so I put this in to trick because you might say, oh, when I can that'll then cancel, but it doesn't. Nothing cancels, so you're done. Okay, so nothing actually simplified when you factored it. Okay, but that would be the idea. So we factored, and nothing cancels. So if I change this question, does something now cancel? So on top we can take out the 3. And on the bottom a 2. The top is a difference of squares. X plus 2x minus 2. Okay, and see they both have the x plus 2. So our answer is 3 onto x minus 2 over 2. Do these 2's cancel? No. Because that 2 right here is not multiplied by the whole top. So that would be it. And what would be the domain that we would put on? We did cancel out an x. Yeah, whatever we canceled, so that was x plus 2, whatever makes that equal to 0 is what we cannot have x equal to. It's like a hole in the graph there. Let me draw it. Okay, so let's practice one with a, not 1. So your first step is to say, can I factor out a common factor? So on the top, can we factor out a common factor? No, because of the 5 and the 3 are both not even, so we can't take a 2 out of those. So we would have to leave that. On the bottom, you can take a 2 out, yeah. All right, so on the top, we're going to factor that. So that is 2x squared minus 5x minus 3. So we want to multiply to give 2 times minus 3, which is negative 6. And we want to add to give whatever b is. b is negative 5. So to give us 6, 2 options. Because what multiplies to give 6? 6 and 1, and that would give a 5 if we subtract them. And 2 and 3, and that would give a 5 if we add them. So let's try 6 and 1. So one of them has to be negative to multiply to give. So this would work? And does that work and give you negative 6? Yeah. All right, so how do we rewrite this? Do you remember? You just did the homework. So 2x squared, and you rewrite the minus 3. And what do you put in the middle? Right, these numbers, but with an x. So minus 6x plus 1x. So that was from the 5. Then you group them and factor out anything that they have in common. So here would be a 2x, x minus 3. And this is just an x minus 3 already. And how do you check at this point? Yeah, those two should have the same bracket, because then you can factor that out. So we can factor out an x minus 3, and whatever we have left over, 2x plus 1 if it's missing. And so there it is factored. So you can go up and put them in here. Does anything cancel? No. Could I change it so that it would cancel? Sure. Yeah, like if I change the bottom to something that had one of those 2 factors in, right, that would cancel. Or, yeah, if I change the whole problem, the top. Right? So, example, if I had the same question on top, and I change the bottom just to be 2x plus 1, say, when we factor the top, we have the same as what's on bottom, so that would cancel. What's left on bottom if the whole thing cancels? Just a 1. So this is like x minus 3 over 1, or just x minus 3. Now we did cancel something with an x in it, so what could we say? X is not... So 2x plus 1 equals 0. Negative 1/2. So x can't be negative 1/2. Okay, and I wanted to do a few that don't cancel because in the real world they don't always cancel, but you should always try. So with numbers, sometimes it's a little easier. If you saw, 45 and 27, you say, oh, those are both in the times tables for 9, so they both have a 9 in common, or, oh, those are both even, they for sure cancel. And sometimes it's not as obvious, 111 over 81. Do they have anything in common? They actually do both divide by 3. I'm not sure if they divide by anything else, but you may not look at them and know. And with these, you may not look at it and know that something's going to cancel until you factor it. So it's always worth factoring. If you don't end up factoring things that could have factored, you end up making a question a lot harder, and sometimes almost impossible if you don't factor it before you do whatever the problem is. Okay, so let's do some common denominator. All right, so I'm just starting with the denominator already the same, and actually already factored, because sometimes the question will be already factored for you, and you just sort of have to finish it. So this is two fractions that we are subtracting, and they already have a common denominator. So how would we deal with that? So here you would just write it as one fraction. And so we've got the bottom the same, so we just subtract the top. So we would have x squared plus 2x minus, put it in a bracket. Why do we need the bracket? Right, you want to subtract that whole top, which is the x and the 2, not just the x. If you didn't put the bracket, you'd probably mess that up. And now you simplify the top. So it's called collecting like terms when you do that. So x squared plus 2x minus x minus 2. That minus has to apply to both of those. You just leave the bottom alone and keep rewriting it. X squared plus x minus 2. Right, because these are the like terms, and 2x minus x is 1x. And now, can the top factor is the question. If it can't, you would be done. But if it can, something might simplify. So two numbers that multiply to give minus 2 and add to give positive 1. So we'll try 2 and 1, plus 2 minus 1. And the x minus 1 cancels. What makes that 0? 1. So that's our domain that we got rid of. So x can't be 1. Okay, so that was subtracting or adding fractions. You would do the same. Subtracting's harder because usually people mess this sign up. So we'll do some more subtracting. We try not to mess the sign up, but they don't start with the common denominator, so you have to first find the common denominator, and then once you have the two fractions with the same denominator, you would go through, right? So let's write this one down. Actually, I'll start it on the new page. Whoops. Okay, so 2x minus 4 over x squared plus 2x minus 8. Okay, so to do a common denominator when you have something that might be able to be factored is you find the factors first. We actually did this with numbers as well, because if you have two numbers, say we have 2 over I don't know, 27 plus 1 over 6. Okay? 2 over 27 plus 1 over 6. What's the common denominator? That's not what we want to do. So I'm glad you said it, because other people want to just multiply them, but that's big. Is there a smaller one? So you could do it big, but when you've got these and then you multiply them, you're going to have cubes, and then you need to do synthetic division, which we're avoiding. So you're actually not going to be able to do the question unless you factor them first. So, what are the factors of 27? 9 and 3? Yeah, so 9 times 3? Sure. You could do 3 times 3 times 3. That's what I was thinking. But 9 times 3 is fine for my demonstration purposes. All right. They both already have a 3 in them. So what could we actually do? They both have a 3. So you don't need to add another 3 into the bottom. It's already there. What do we need on this one? A 9. And what do we need on this one? A 2. So the common denominator is actually 54 instead of whatever 27 times 6 is. It's smaller than that. Okay, that keeps the number smaller. So that's what we're going to do, because if they have something in common, you don't need to then multiply it by the other one. You don't need to multiply these both by another 3, because they both have a 3 in common already. That's already there. You just need all 3 of these factors to be in both. Okay, so just this would be 4 over, and even if you didn't know this, you could leave it at 9 times 3 times 2. That's what we're going to do with the factoring. These are both the same denominator now. You could make them look the same by just writing them in the same order. 4 plus 9 over 2 times 3 times 9. What's 4 plus 9? Do they have any factors in common? The bottom's still factored. I didn't multiply it out, so I can actually see. Does 13 break up into 2 times anything, 3 times anything, or 9 times anything? No, so we're done. And then you could work that out if you wanted to. 27 times 2, and that would be it. Now, we're going to do the same thing with this, and we're going to leave the factored on the bottom. We're not going to expand it back out. We're going to leave it factored, because then you don't need to refactor it to see if something cancels in the end. If I had written this as 54 right here, then when I get down to the end, I'd have to say, okay, what are the factors of 54? Do they have anything in common with 13? And then I'd have to refactor it when it was already factored earlier. Okay, so we're going to do the same thing. So we're going to factor. What factor's on the top here? A 2 comes out. On the bottom, so two numbers that multiply to give negative 8. 4 and 2. And I want them to subtract to give a positive 2, so I need the 4 to be plus and the 2 to be minus. And just double check, 4 minus 2 is positive 2, and 4 times minus 2 is minus 8. Now what about over here? Two numbers that multiply to give 12. 4 and 3. And it's just both plus, so that works. Okay, so there's two ways to look at this now. What do you think? ideas? You can cancel out the x minus 2 and make this fraction smaller to start with. What would that be like doing in numbers? What would be an example? Like if we had 2 over 14 to start, do you see the 2 over 14 actually can be made smaller right away? 1 over 7. And now we've got smaller numbers to work with. So that's what's happening here. This one fraction had something in common already before we started, so we could cancel that out before we add them. Now we have to remember that x can't be 2. We canceled that out, so we have to write that in at the end. So I'm just going to keep track over here. Okay, anytime you cancel something with an x, you have to write down that domain. Okay, so what do we have? Here it is. So what's the common denominator? They both have something in common. They both have the x plus 4. So this one doesn't need anything else, but this one is missing the x plus 3. So put that on both top and bottom. And now we will have 2 times x plus 3. Now, as soon as you do the common denominator, don't cancel anything, because then you're going back to where you were. I could cancel here because it was before I started the common denominator. So I just wrote, I can cancel before I do the common denominator, but then now I've done the common denominator, don't cancel after the common denominator. Why not? Yeah, we're undoing this. We just multiplied the top and bottom by the same thing, so we're not going to then cancel it out. Then we'd be back to here, saying, okay, what's the common denominator? Multiply top and bottom by x plus 3. Get down here, cancel it out. Okay, what's the common denominator? Right? Don't cancel out your actual common denominator. You're just going to go in a circle. Okay, so now we have the bottom the same. We then write it as one big fraction. There's just a plus 1 on top here. Leave the bottom alone, just like I left the bottom alone over here. Leave it alone because it's already factored. We want to use that maybe later. And just expand the top. So this 2x plus 6 2x plus 7, does that factor? Does anything cancel? No. Can we factor, 4 plus 3 is 7. Don't get excited because you can't cancel anything unless it's multiplied. Can you factor out something up here? Between 2 and 7? No. So does this 2x plus 7, does that appear on the bottom somewhere? No. So this would be the answer, except we did cancel out an x somewhere in the problem. So we do want to say that x can't be 2 from where we canceled it out earlier. Same thing. So we're going to factor the bottom. And then we'll compare them and see what it is the common denominator should be. The top doesn't factor. And these are just when A is 1, so they're just the easy ones. You don't even need to write them off to the side if you don't need to. Two numbers that multiply to give 30. Yeah, I was thinking 3 and 10, but that won't work because it won't give us 11. But 5 and 6 will. Both plus. Right, that'll add to 11. 20. 2 and 10 doesn't give us a 9. 4 and 5. Both plus will give us a 9. Okay. Okay, so now nothing cancels before we start. So what would the common denominator, what's missing on this piece that is over here? The x plus 4. So we want to put that x plus 4 on both the top and bottom of this. Now they have these 3, so this needs to have the same 3. So which one is missing over here? The x plus 6. Okay, don't cancel anything because we just did the common denominator. So now we want to write it as one big fraction with an x plus 4, an x plus 5, and an x plus 6. Because you can write them in any order. Remember, when you multiply, it doesn't matter the order you put them in. But the bottom is the same on both fractions, so now we write the top. So what's on top of the first one? X was already there times x plus 4 minus 5 times x plus 6. Leave the bottom alone. If you expand it, then you're going to get a cube, and then you're not going to be able to factor it again. So when we work out the top, x times x, x squared, 4x, minus 5x, minus 5 times 6 is minus 30. Uh, 4x and 5x. Okay. So we've taken our two fractions, we've factored the bottoms, found the common denominator, wrote it as one fraction, and now can we cancel anything? Maybe. What do we have to do? Factor the top. So 30, I think 5 and 6. So if one's a 5 and one's a 6, we wanted to add to give a negative 1. The bigger number has to be negative. Now, does anything cancel? The 5. So once we cancel that, remember x can't be negative 5, so we want to keep that with our answer. So if we write out our final answer, we have x minus 6 over x plus 4 times x plus 6. The x plus 6 and x minus 6 don't cancel because they're not the same thing. But we did cancel out an x plus 5, so x can't be negative 5. Yep.
Could you take a negative 1 out of the top?
No. It would then be, if we factor a negative out of the top, we'll have negative x plus 6,
Oh, yeah.
which is not the same. So if you factor a negative out, it changes both signs, not, yeah. Okay, so you can actually do that whole homework now, but don't. Study for the test instead. Okay, and then we'll finish this section on Wednesday and start the next section. Oh, yeah, sure.
Well, it's, taking down notes, I realized that I didn't state how much.
Maybe take them over there.